In a previous video, we talked about the slope of a line. And now it's time to talk about how parallel lines and slope are related. So, one fact that we're going to discuss is that parallel non-vertical lines have the same slope. So let's discuss why this is true. So suppose that you have two non-vertical lines. And these are going out forever, right? Because these are lines. Okay. Now draw a vertical line that passes through them and draw a horizontal line that passes through them. Now you have these two triangles, say A, B, let's say C, D, and let's call this the origin O. So you have these two triangles ABO and CDO. Well, these are both right triangles. And so let's call this line L1 and let's call this line L2. So these are both right triangles. Now since L1 and L2 are parallel, what can we say about these two angles? They're congruent, right? They have the same measure. So angle BAO is the same as angle DCO. Now I'm being a bit sloppy, which is, I guess it's okay. I mean, technically I should say that the measure of angle BAO is the same as the measure of angle DCO, but we know what we mean. These two angles are the same. So therefore, we have two triangles with two corresponding angles being the same. Therefore, all the corresponding angles are the same. So therefore, triangle ABO is similar to triangle DCO. And when you have two similar triangles, okay, we can compare the ratios of the side lengths. So therefore, BO over AO equals DO over CO, and BO over AO is the slope of AB, DO over CO is the slope of CD, so L1 and L2 have the same slope. So again, we have the key fact that we're using is similar triangles. When you have parallel lines and you're trying to say something about parallel lines, it's a good idea to try to incorporate some triangles, because then you're going to get some similar triangles. So if you have two parallel lines, they must have the same slope, which makes sense intuitively because the slope is the measure of the steepness of a line. And if you have two parallel lines, when you draw the picture, you can see that they will have the same steepness. But that's, yeah. So intuitively, that's why parallel lines should have the same slope. It would be surprising if they somehow had different slopes. What about if you have two non-vertical lines that have the same slope? Now, could it possibly be that you have that you have two intersecting lines that somehow have the same slope? So we just explained why if you start out with two parallel lines, they have to have the same slope. But is there any other possibility? Like, could you have a line and then another line that's not parallel to it that somehow have the same slope? Well, it turns out that that is not possible, and that's from the following fact. If the slopes of two lines are equal, so remember, when we say that when we're talking about the slope of a line, we mean that the line is not vertical. So in the statement, if the slopes of two lines are equal, in that phrase, the assumption is that we have non-vertical lines, because vertical lines don't even have a slope. So if the slope of two lines are equal, meaning the slope of two non-vertical lines are equal, then they are parallel. And why is that true? Well, suppose that they were not parallel. So suppose that there are two two intersecting lines with the same slope. So this is a proof by contradiction. We're going to suppose that there are two intersecting lines with the same slope and then see what goes wrong with that. What's wrong with having two intersecting lines with the same slope? Well, let's say that you have one line like this and one line like that, and these are intersecting lines, and suppose that they had the same slope. Okay. So suppose that L1 and L2 have the same slope. Well, since they are intersecting lines, they have to intersect somewhere. So let's call this intersection point P. And let's look at the point 1 unit to the right of P. So draw a horizontal line through P and look at the point that's 1 unit away to the right of P. So let's say this is 1 unit. Okay. Now look at, I made this picture a little too small. Let's look at the parallel line through Q. Okay. The vertical line through Q, this line. Now this line is going to intersect both lines at certain points. So let's call this point R and let's call this point S. Okay, so before we continue, let's write down what we did. So suppose that there are two intersecting lines, L1 and L2, with the same slope, and suppose that they intersect at the point P. Okay. Let Q be the point 1 unit to the right of P. Okay. And okay, let's call this blue line L. Okay. So we let L be the vertical line through Q, and let L intersect L1 at at S, and let L intersect L2. Oh no, wait. L1 and L are intersecting at R, and let L intersect L2 at S. And let's say that this common slope is M. That's typical notation. It's typical to call the slope of a line M. Okay. Well, then these two lines have the same slope, and so SQ over PQ must equal RQ over PQ, because SQ over PQ is the slope of L2, right? So this is the slope of L2, and that's the slope of L1. I'm assuming that L1 and L2 they have positive slope. Okay, so let's assume that M is positive in this case. Okay. If they both have negative slope, then the slope of L2 and the slope of L1 would be just minus SQ over PQ and minus RQ over PQ. But either way, SQ over PQ will equal RQ over PQ. Well, PQ is equal to 1 by definition of how we define Q. So SQ is equal to RQ. Right? But what does that tell you about the 2 points? Then S must be equal to R. Right? Yeah. SQ is equal to RQ. How does that contradict the assumption that L1 and L2 are intersecting? So if SQ equals RQ, so R is S. Well, then L1 and L2 both pass through P and R, right? If R and S are the same point, then both L1 and L2 pass through P and R. Well, therefore they are the same line. And we assume that L1 and L2 are not the same line. So that's the contradiction. So we wanted to show that if the slopes of two lines are equal, then they are parallel. If they weren't parallel, So we should say two different lines. If the slopes of two different lines are equal, they are parallel. I mean, we're obviously assuming, I should have been more specific, but I mean, obviously we're assuming that the two lines are not the same. So when we're saying two lines. So we have two different lines. We want to show that if they have the same slope, they must be parallel. And we explained how if they were not parallel, and they somehow had the same slope, then that would mean that the two lines are the same, which is a contradiction to the fact that they are different lines. So what did we prove when you put this theorem, let's call this a theorem, together with this theorem? Parallel non-vertical lines have the same slope, and if the slope of two different lines are equal, then they are parallel. That means that if you have two parallel lines, then the slopes are equal and vice versa. Okay. That means that if you have two lines with different slopes, they must intersect. So let's just record two lines with different slopes must intersect. And if two lines intersect, they must have different slopes. That's another way to rephrase the two facts that we've proven. Okay, thanks.